Alrighty, so today is lesson 7, different bases, same exponent. So you have a warm up. Okay, so evaluate. So part of our rules would tell us, try to move some of the stuff out of the way. Here we go. That we know this is really 2 to the 5th power. So then you would want to evaluate that. So your 2 times 2 times 2 times 2. Okay, so 2 times 2 times 2. This would be your expanded form. Well, that makes 4. This makes 4. That makes 16 times 2 is 32. So hopefully that, for those that are having problems with their exponents, that helps. All right, 10 to the 7th power. So you're going to add your exponents, which means then you have 10 million. And then this one, they're not the same, are they? So 10 squared is 100 times 4. So that would actually be 400. And that's what we're going to talk about today is how can we take things with different bases but the same amount of exponents and make it a little bit easier. Alright, so activity 1 is the table. If you're doing this online, you'll probably be broken down in this for you as well. Alrighty, so the way you really are setting it up, you want to find out what 3 times 4 is, and then you keep your 3 exponent. So we end up with 12 to the 3rd power. Okay. So then expanded form, well, I have 4 2's times 4 3's. And that would make then how many groups of 3 times 2 times 3? Well, that would be 4 of them. So 2 times 3 is 6 4 times. So we get 6 to the 4th power. We're not evaluating. It doesn't tell us to evaluate. Working backwards can be a little bit different because there's a lot of numbers you could multiply to get 15. You could use 2 and 7.5. You could use 1 and 15. We'll keep it basic and we'll use our 3 and 5. Now, what exponent should we use? Well, what exponent do they have over here? So to the 3rd, to the 3rd. And then you would write that out as well. That we would have 3 times 3 times 3 times 5 times 5 times 5. And then I would break it down. 3 times 5, well, it's 15. Times 3 times 5, 15. 3 times 5, 15. So that's how we got 15 to the 3rd power. Same thing with 30. There's multiple of those that we could do. Okay. I would say let's go with 3 and 10. Okay, so we know 3 times 10 will make 30, and we want it to the 4th power. Like I said, you could use multiple. There's multiple ways to get 30 in multiplication. And then your expanded form. 3 4 times 10 4 times. And then we get 30 4 times. That's why it's to the 4th power. Alrighty. 2 to the 5th power times x to the 5th power. Okay, so now we're going to throw in some variables. Okay, so I have 2 5 times. times x. Oops, that's not an x. 5 times. Yep, that's 5. So then we end up with 2x. We paired each one up 5 times. This is one of those I like the exponent laws because they're easy to catch on once you're told how to work with them. You should be able to figure them out. It's just you have to be told what the laws are. So then we have 2 times x to the 5th power. All right. Now, we also have to put parentheses around this because otherwise the x is the only one being taken to the actual power of 5. And we want the 2 as well. Now, could you put 32x to the 5th power? That would be another way you could write it as well. But that means you evaluated the 2 out and they don't want it evaluated yet. Alrighty. So 7 times 2 times 5. Well, it'd probably be easier to go 5 times 2. Well, 5 times 2 is 10. And 10 times 7 is 70. So we would have 70. I'm skipping, writing it out. Don't have a lot of space. And then it would be 70 to the 3rd power. What patterns do we notice? Okay, that's kind of, they want you to be able to tell them what's the rule. Multiply bases. Keep same exponent. Now remember, your base is the bigger number on the left and your exponent's the smaller number on the right. So we multiply the bases out and then we keep the same. So you're not adding or subtracting your exponents this time. Alrighty. Next one is whether it is true or false. Now, if you want to give it a try on your own, go ahead and pause the video and see if you can do these on your own. Now, it also says to give an altered equation, kind of like if it's a false, fix it. Okay, that's even in the instruction. If it is false, change one number to make it true. So you slow down and read your equations. So first thing, when I would look at number 1, I'm like, all right, so we should have a 3 exponent. Yep. And then what's 4 times 6? It is 24. So that one is true. Okay. Then this one, yes, 5 times 8 is 40. But what did they do with their exponents? They added them. So they should have kept it as 40 to the 7th power. Okay. Then what about this one? There is one thing that they made a mistake about. This one is a false. Notice how there is only the exponent to the 4. The 4 to the 2. They forgot their parentheses. When you have fractions, remember you either need to put parentheses or you need to write it with the 4 on both the numerator and the denominator. Okay, either of those would be the correct way. You could even go so far as say 2 to the 4th power times 1/3 to the 4th power. All right, number 4 is true. They wrote it correctly. Okay, so when you have those parentheses, it means it's almost like distributive property, but with exponents. You're applying it to both terms inside. And the same thing about number 5. Okay, what about number 6 and 7? Well, we do get 80, but what did they do with our exponent? They added them. We're not supposed to add them when we have different bases. We have different bases. We've got to keep that 4. Same thing on this one. It should be AB to the 7th. Or you could say A to the 7th and B to the 7th. That means the same thing. And let's see. Well, they kept the power of 7, so that's good. Well, we have 18 to the 7th times 8 to the 7th. And 18 times 8 is 144. So that one was written correctly as well. Alrighty. So here's your summary, kind of retelling you about the rules. Okay. Now remember our other rules that we had. If you have a to the n times a to the m, you add n plus m. Okay, that's the same base but different exponent. So that's opposite of what we had today. Or say we have b to the t over b to the w. Then that means you would subtract the numerator exponent from the denominator exponent. And our other rule that we've talked about was a power of a power. So if I have g to the f with h on the outside, we multiply those powers. Alrighty, so those are all the rules that we have. Okay, what we did today, where you would multiply out our bases and then keep our exponent. So now you're going to do problems 1 through 4. Alrighty, have a great day, and I will keep you posted on Miss Gwen.